30 seconds and counting. 25 seconds and counting. We are still go. 20 seconds. Guidance alert. The guidance system now going internal. 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence start. 5, 4, 3, 2, 1.
Oh, hi, we're live. How about that? Hey, guys, sorry about that. Didn't realize that we were counting down. I apologize, but here we are. And guess what? For the first time, we are actually in two different formats for this live stream, both in horizontal and in the vertical shorts / TikTok kind of format here on YouTube. And we've got people watching there too. So hello. If you guys are brand new to this channel, this is the Angry Astronaut. I do a lot of rather blunt and opinionated views on space flight, and we are covering a very big event right now, and that, of course, is the next landing on the moon, what will hopefully be the United States' first perfect landing on the moon in over 50 years, even though we did have a close to perfect landing a few months ago. Wasn't entirely perfect, and so now we're hopefully going to have a Firefly is going to do the job. So to give you an idea of why are we landing on the moon right now, what's the deal with all of this today? Well, it's because of course we have a plan to return to the moon, and this return to the moon is a lot of private companies involved compared to where we were before. And bear with me, I'm just pulling up some information as I am talking to you. So real quick. Yes, and let's go ahead and see, where's everybody checking in from too. We absolutely want to check in with that. Boy, we have almost 200 people watching. We have Cambridge, UK. Sorry, I was just pulling up the chat here. Hello, Arkansas and Tampa. Hello, Malaysia. Thank you very much. And Dundee, thank you for checking in. Hello, Minnesota. Really appreciate you checking in today. Let's see, from my bed, it's cold this morning. Yes, it is dystopian. Southampton, hello. And where else? NorCal. And Michigan, hello Stuttgart, and hello Hong Kong and Buenos Aires, hello Wisconsin and Pittsburgh, hello Maui, hello Sydney, hello Pennsylvania, hello Indianapolis, hello Kentucky, hello Michigan, Niles, Michigan, and hello South Orange County, California, and New Zealand. Monty, thank you very much for checking in from New Zealand. I like covering Firefly, what am I saying? Rocket Lab a lot. For those of you who are not quite as familiar with my channel, I covered them quite a bit. Hello, Cape May, New Jersey, and Auckland and Seattle, Arkansas, Oklahoma border, Portland, hello, Portland, and Vienna, hello, Wien. Love Wien, by the way, such a beautiful, beautiful city. My first time visiting it just a couple of months ago. Queensland, the moon, Hungary, British Columbia, all over the world as usual. It's something I just love about this job and about YouTube is I get to meet people from every walk of life from all over the world. So super excited about that. So once again, to revisit the Artemis program to land on the moon, we'll have humans hopefully setting down on the moon in 2027, maybe 2028. I'm thinking is going to be a little bit more realistic. We got more people. Hello, Michigan, and Dallas, Phoenix, Syracuse, another New Zealand looks like, Windsor, Connecticut, another Michigan, Thanks again for tuning in, everybody. So, the idea is to do a number of unmanned landings on the moon first to gain as much scientific information as we can about the lunar surface before we send humans there. Now, granted, we've been there before, but the big difference is there's been a lot of advancements made technologically since that time, and still quite a number of unanswered questions about the moon. Radiation levels being a real key thing that wasn't quite as big of an issue during the time of Apollo, simply because the Apollo astronauts didn't spend much time on the moon. They were only there for a few days, and only a few days total, including the travel to and from. Instead, we're going to be looking at stays of up to 60 days this time, and perhaps even longer with some of these missions. So, with that kind of long-term exposure to solar radiation and cosmic rays, it could be a lot more problematic than it was in the past. So we need to get an idea of exactly how bad is that radiation at all times of day and night. And of course, the lunar night being 14 days, daytime being 14 days, because lunar rotation remains constant. In other words, the same face of the moon is always presented to us because it's something called tidally locked. So that being the case, you don't have any rotation and 14 days between day and night for any given point on the moon. Although at the polar areas, especially the South Pole of the moon, there are some areas where you really kind of have a twilight year round, in a very similar way to how that happens at the North and South Pole here. And that being the case, you can get nonstop sunlight in a few select areas of the polar regions. So in the future, that's going to be important too, because if these areas actually do get enough sunlight to support solar panels, for example, that sort of thing, solar power, then maybe we can use solar power in those regions of the moon. But if not, then you have to look for other alternatives. It gets ridiculously cold on the moon at night. We're talking one of the coldest places in the universe during those 14 days when the moon is out of sunlight. And that being the case, it requires a lot of power to heat life support, to heat a lunar habitat, keep the astronauts alive. It's going to be quite a challenge, and so nuclear power may be the only way to make that work if we can't make effective use of all of this. So, in any event, let's see, what is Blue Ghost mission and profile post landing? Well, first of all, let me tell you what Blue Ghost is. Blue Ghost is the lander from Firefly that's going to be setting down on the surface of the moon. And again, the difference about this program is that during the Apollo era, all of these were government missions. And so private companies, of course, would build the spacecraft, but still they would be exclusively government missions. In this case, the CLPS program, as it is called, is a commercial lunar program. And so therefore, that being the case, there are a number of private companies who have their own agendas. So the Blue Ghost actually is not a probe with any sort of significant equipment on itself as a spacecraft. Instead, it has decks which carry cargo from a variety of different customers. So there's and it's going to be operating only for about 2 weeks, unfortunately. And during that time, there's a number of experiments that are being that have been delivered by a variety of different companies. NASA, of course, delivering quite a number of them, but not necessarily the majority. And then these experiments will be implemented over the course of a 2-week time frame. Bear with me for just one moment. I actually released a video about this topic, and let me give you a quick rundown of the companies who are on board. Just one second here. All right, because it is a wide variety of them. So Blue Ghost Mission 1, I'm just going to go ahead and pull it back up. I can't commit all this stuff to memory, unfortunately. So let's see who's on. Okay, so here's what we have. We have the following experiments, the following pieces of equipment on this lander. You have the Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity. In other words, the Lister. It's actually a drill to pierce down into the lunar regolith to get some information about the composition, perhaps the presence of water, that sort of thing. The lunar planet vac to suck up regolith. Also, the next generation lunar retro reflector. You have the regolith adherence characterization, or RAC, from Aegis Aerospace. Also, by the way, University of Maryland does the retroreflector. Honeybee Robotics does the planet vac, and Honeybee also does the that drill, the Lister drill. Also, you have the radiation tolerant computer. And remember what I said about radiation. This computer is designed to test the resilience of the of different types of microchips and different types of computer systems that might be deployed on the moon. Radiation does nasty things to these types of systems. So this computer is designed to be resistant to radiation. They're going to see just how resistant, how well does it hold up over this couple of weeks. And again, the radiation tolerant computer from Montana State University. You also have the electrodynamic dust shield from NASA Kennedy, and lunar dust. Big problem. These microfine particles of dust that were a real hassle for the Apollo missions. If you breathe this stuff in, it's very hazardous. And so it's extremely important that we find a way to get this stuff off of astronauts before they re-enter a lunar habitat or a lunar lander. So this dust shield is designed to test the ability to do that. The Lunar Environment Heliospheric X-ray Imager, and this is Boston University, NASA Goddard, Johns Hopkins University. The Lunar Magnetotelluric Sounder, or the LMS, from Southwest Research Institute. The Lunar GNSS Receiver Experiment. This is this particular piece of equipment is to experiment with communications between the moon and Earth. That was the Italian Space Agency, by the way. So that's a European cargo on board. And then you have the stereo camera for lunar plume surface studies, or the SCALPS. This one is extremely important as well, because this camera will be deployed at the last second as the probe is beginning to land on the surface of the moon, in order to study how much of a plume it kicks up, how much dust, how much debris gets kicked up by the lander's engines as it's setting down on the surface of the moon. The reason that's important is because we're going to have much bigger spacecraft, such as Lunar Starship, a colossal 100 ton without cargo, without fuel, without anything, this massive thing setting down on the moon. And even though it's going to be using scaled down thrusters, so it lands a little bit more gently and doesn't kick up as much dust, it's going to kick up way more debris than anything that we have ever put on the moon before, by far. And so we need to get an understanding of just how bad the potential impact of lunar debris or lunar plume is going to be when these spacecraft set down, because we absolutely don't want to have a spacecraft damaged as it is setting down. So here we go, 83 minutes to scheduled landing. Yeah, that could be. They'd have photographed some dozens of minutes after that. Very possible. So in any event, here we go. They are going to, by the way, Firefly is scheduled to go live in about 8 minutes. We, of course, will be bringing you their broadcast as well. We'll cut out from that broadcast periodically if it's appropriate for me to make some additional commentary, or if there's any copyrighted music that Firefly is playing at any given moment, then we're going to have to mute them for that. So in any event, that's how this is going to run. Over 300 people watching right now. Wow, we got a big crowd. Really appreciate it. I'm very happy to see that we have this enthusiasm. And we have 56 people watching the shorts feed as well. I suspect that a lot of those people may be brand new to the channel. The folks who are watching on the shorts, the vertical side of it. If so, welcome to the Angry Astronaut, and thanks for joining us today. To any new viewers we might have, regardless of where you're watching from. But my producer came up with an idea of let's go ahead and do this broadcast in a vertical format as well, because a lot of people who like that, to see if there'd be any interest in it. Apparently there is. So it's super happy to have you folks with us. And yeah, well over 350 people in the current in the current crowd. Hello, Cornwall. Thank you very much for checking in, and hello, Calgary, and hello, Dublin. Really, really appreciate it. So yeah, a lot of experiments on this thing. We're looking at a total of 10, actually. Now, another question that folks might ask is, why did it take so long? There's been a lot of unhappy comments made by people who either remember Apollo or people whose parents remembered Apollo, whatever. And it took just a few days to get from Earth to the moon. Even the unmanned missions, for the most part, only took a few days. What's the deal? Why weeks and weeks? Have we just gotten worse at this? Well, no. A big part of the CLPS missions is that these are private companies and they're trying to make a profit. This has to be profitable for them. And so therefore they're getting the cheapest ride to the moon possible, the least expensive ride to the moon. So what they chose was a reusable Falcon 9, which costs about $60 million, which is about $40 million less than a more powerful rocket such as Vulcan Centaur or a Falcon Heavy. If either of those rockets were being employed, then yeah, they could have gotten to the moon in a few days. That the Blue Ghost definitely could have made the journey. But with a Falcon 9, first of all, not as powerful as a Vulcan Centaur, certainly not a Falcon Heavy with three boosters, but also in reusable format. What that means is that the booster is cut off early in the ascent, with a rocket with an expendable booster, as Vulcan Centaur is currently anyway. Vulcan Centaur is going to have some reusability built into it later, but the booster uses every drop of fuel that it can to gain as much altitude as it possibly can before there's a second stage separation. And for interplanetary missions, that makes a very, very big difference. Falcon 9 only gets up, the booster only gets to a certain altitude before it has to cut off so that it can realistically return to a landing barge, and it has to keep some propellant in reserve also in order to make that landing. Therefore, it can't carry as much payload, for one thing. And number two, it definitely can't deliver a lot of payload to interplanetary destinations. It can deliver some, but not a lot. Falcon Heavy usually is a much better rocket to use for those sorts of applications, because you can use that center booster. Sometimes it's enough even with all three boosters being reused, but for interplanetary missions more frequently, SpaceX expends that center booster. They use every drop of fuel to get as much altitude as they can before the main engine cutoff and stage separation. Much more effective to deliver significant payloads to interplanetary destinations. So since they didn't do that, since Firefly didn't do that, and a number of other companies haven't either recently, they only got so far before Falcon 9 ran out of gas, essentially. And so as a result, they have to use the Earth's gravity and then the moon's gravity eventually in order to do the rest of the job, doing consecutive flybys, one after another, gaining more and more velocity as time goes on, gaining more and more altitude until eventually they can transition to TLI or trans-lunar injection orbit and then eventually get to the moon. It takes a very long time, comparatively speaking, but it does save $40 million for the company in question. And again, if they make an extra $40 million worth of profit off of the mission, $40 million is a lot of money, and they can do a hell of a lot with that extra cash. So yeah, that's the deal. Let's see here. What else? Just checking some of the comments. So yeah, a little bit. My understanding is a little bit more than an hour before the landing. Of course, we need to keep in mind that it's hard to schedule an exact time because here in 12 minutes, Firefly will be going live, or is it in? It might actually be sooner than that. I apologize, producer. What time are they going again? All right, so Firefly is actually going live here in a second. All right. Yeah, let's go ahead and bring Firefly's the screen up right now so we can go ahead and have a look at. Sure. Producer's going to take a moment here, and then we'll go ahead and bring Firefly up. But they're going to perform a braking maneuver and then determine whether or not they're in a safe situation, in an optimal situation to go ahead and pursue a landing on this orbit. If for some reason there's any sort of technical issue or something that isn't quite perfect about the trajectory, then they're going to go ahead and do another orbit and attempt it again and about an hour later. So we can't say for certain exactly when this landing is going to take place, but most probably we're a little over an hour away. Yep, copyrighted music. Got to make sure that we don't. But the producer's real good at that, by the way. Our producer is incredibly skilled when we're talking about that, getting rid of copyrighted music. So we always show as much appreciation to our producer as possible to keep us away from those sorts of things. All right, so we just bear with me for one moment here. All right, we are about to go live from Firefly here in just a moment. So we're going to keep our eyes on that. And the moment that they do go live, we'll go ahead and cut them in and bring you all of the details from then. And of course, I will maintain my commentary as well. Seems to be a lot of interest in this. There's over 10,000 people watching this broadcast. So yeah, but really appreciate the over 400 people watching here. This is a big crowd by my standards. So really, really appreciate you guys being here, and we'll continue to bring you more and more details of this landing as we get closer. All right, so Firefly's Operations Centers is now live. Producer, are we going to bring them on?
Launching from Kennedy Space Center. Welcome to the live landing coverage of Firefly's first
road
trip to the moon.
Okay, we're going to go ahead and bring Firefly
with our Blue Ghost
on
lunar
for you
lander
folks.
delivering NASA payloads. I'm Bridget Oakes, the Vice President of Engineering at Firefly.
And I'm Nilfer Ramji with NASA Communications.
And for the past 6 years, I've worked with our engineering teams on everything from avionics and software to composite structures and propulsion systems for our rockets and spacecraft, including Blue Ghost. And today, I'm honored to be supporting the Blue Ghost team as your Firefly host.
Thanks, Bridget. And Firefly's Blue Ghost Mission 1, called Ghost Riders in the Sky, was awarded through NASA's Commercial Lunar Payload Services, or CLPS initiative. With NASA's Artemis campaign, we are returning to the moon to conduct groundbreaking science and leverage technological advancements before people go back. Today's moon delivery with Firefly Aerospace will help us continue on that path. And later on, Blue Ghost Mission 1 is set to touch down on the lunar surface carrying 10 NASA science and technology instruments. Just over an hour from now, we will attempt to land in Mare Crisium, a basin in the northeast quadrant of the moon's near side, or the side we see here on Earth. A little south of Mare Crisium, you will find Mare Tranquillitatis, or Sea of Tranquility. That location might sound familiar since that's where the first Apollo astronauts landed on Apollo 11 in July 1969. That's over 55 years ago.
This Blue Ghost mission has been a journey not only for our Firefly team, but the friends and family who have supported us. More than 750 Firefly employees have played a role in bringing this historic mission to life, and their loved ones have been an integral part of this journey. This impressive team is joining us now with our NASA customers, watching from a viewing location just down the road from our Mission Operations Center.
I want to be there. We're joining forces for this historic moment marking Firefly's first lunar landing. It's all hands on deck since years of preparation have gone into this exact moment.
And before we touch down, let's go ahead and review our current mission status. Blue Ghost just entered a planned comms blackout on the far side of the moon where we have limited access to our ground stations on Earth. As you can see in our telemetry-driven simulation, the lander is currently in low lunar orbit, about 100 kilometers above the surface as we get ready for our descent orbit insertion, which is going to be in about 10 minutes. This critical 19-second burn will put Blue Ghost on its descent trajectory, and then we'll coast for about 50 minutes. Comms should be back online about halfway through that coast phase. We're going to walk through these steps in more detail later in the broadcast, but in the meantime, you can track the mission progress in the timeline bar at the bottom of the screen. And throughout the show, you'll see even more graphics that are driven by our real telemetry data from Blue Ghost. This includes our countdown clock in the top left corner of our gauges are going to be just under that clock, which show our velocity and distance above the moon's surface. Those gauges are frozen now, but will activate once we reacquire signal with the lander. The simulation you see is about 15 seconds delayed, so we'll be landing on the moon just before you see it on your screen. We also have a graph that will show Blue Ghost's descent phase in real time. And we have a view of the lander's footpads and thrusters. As we get closer to descent, this graphic will show us which thrusters are firing and which footpads have actually touched down on the surface after landing.
So for now, let's take a look back at the 6-week-long journey that led us to this point and got us closer to the moment we've all been waiting for, Firefly's first lunar landing. Blue Ghost launched on a SpaceX Falcon 9 rocket in the early morning hours on January 15th from Launch Complex 39A at NASA's Kennedy Space Center in Florida. About 6 minutes after the launch, Blue Ghost separated from Falcon to begin orbiting Earth before it went into lunar orbit. The lunar lander acquired signal about 9 minutes later, which was followed by completion of on-orbit commissioning. That moment officially kicked off that 45-day journey that's brought us here to today. Now, what you may not know is that Launch Complex 39A is where the historic Apollo missions headed to the moon. That must have felt symbolic.
Absolutely. And it was a proud moment, and a huge shout out to SpaceX for being such an incredible launch partner. Blue Ghost was deployed into a highly elliptical Earth orbit about an hour after liftoff. We then completed a 45-day transit from Earth to the moon. And this mission has been incredibly successful to date, and we're so proud of what our Fireflies and NASA have collectively accomplished. So far, we've already downlinked 27.2 gigabytes of data, including some incredible payload science from NASA. We conducted 7 engine burns during that transit for a total of 523 seconds and traveled roughly 2.8 million miles.
Wow.
This included 25 days in Earth orbit where Blue Ghost took a phased orbital approach with
TC Mutt, thank you so much. $50 Australian.
Closer to the moon.
Thanks so much. By the way, guys, I'm giving away some free merchandise to a random super chat supporter this month. We're going to show you some of that merchandise later in the broadcast.
To enter the moon's orbit, where Blue Ghost spent the last 16 days. Additional maneuvers were performed during this time to enter a low lunar orbit. This brought us to about 100 kilometers above the moon. That's where the lander is right now as we get ready for our descent orbit insertion.
No pressure, 100 kilometers. And during Blue Ghost's road trip to the moon, Firefly was able to downlink some pretty incredible imagery. Let's take a look back at that footage. So without a doubt, no matter how many times I see these, I am proud, inspired, and frankly speaking, just blown away at how stunning our Earth and moon look in the darkness of space. Now, when you're headed to the moon, that trip can vary depending on the selected route. Some might be a lot quicker than others, but Firefly chose that scenic route.
We did, and there are a lot of benefits to that scenic route, actually. With that 45-day transit, we were able to conduct rigorous health checks on each Blue Ghost subsystem and on each of those NASA payloads. This route also gave us ample time to calibrate our propulsion system ahead of each of those critical maneuvers. We could then analyze the data from each burn so we could better predict performance and optimize our trajectory. Once we entered lunar orbit, we also had more time to calibrate our vision navigation system and verify its operations, which enable that precision landing. And most importantly, we were able to conduct payload science operations throughout that road trip and capture some incredible data for our NASA customers.
Our NASA payload teams are pleased with the science and tech operations they have been able to conduct while Blue Ghost has been in transit. Among the 10 NASA instruments being delivered, I'm happy to share that all of them are expected to be healthy, so they are ready to work shortly after we touch down on the moon this morning. We'll be talking through the largest CLPS manifest to date in more detail later on, but off the top, we do have a couple of key highlights we can share. The Lunar Global Navigation Satellite System Receiver Experiment, or LUGRA, tracks signals from the Global Navigation Satellite System at a record-breaking distance of over 200,000 miles while Blue Ghost was in transit. This data can help enable GPS-like solutions on the moon, which is really exciting. LUGRA is a collaboration between NASA and the Italian Space Agency. Another instrument, the Radiation Tolerant Computer, or RAD-PC, also began demonstrating the computer's ability to withstand space radiation while passing through the Van Allen radiation belts. I'm personally looking forward to the surface operations to collect more of that important data and science. But before we get into that phase of the mission, we're getting really close to that next milestone.
Blue Ghost is set to perform its descent orbit insertion burn in just a matter of minutes, which will place the lander on its descent trajectory. As mentioned, this 19-second engine burn is performed on the far side of the moon during a planned comms blackout. So we're going to check back in with the team to confirm if it was successful once we reacquire that signal. If anything is off nominal, we'll actually get another shot at the descent orbit insertion. If everything looks good, though, then Blue Ghost will continue through its coast phase. We'll then perform a powered descent initiation and begin our D'Souza guidance phase around T-minus 12 minutes to landing. We'll talk more about each of those phases as we get closer, but in total, our entire descent takes about an hour.
And this entire descent phase is autonomous, right? So meaning she's built and programmed to do exactly this.
Exactly. However, Firefly does have the ability to override the descent and send commands to the lander as needed up until that powered descent initiation, or the braking burn.
Got it.
That lasts about 9 minutes. It's at that point that we let Blue Ghost take the wheel before touching down in Mare Crisium. If you're looking at the moon from the Earth's northern hemisphere, it's a large basin that's located in the northeast quadrant of the moon's near side. This landing site was actually chosen by NASA. Can you tell us a little bit more about how that decision was made?
Yeah, of course. The landing site selection for CLPS has been an interesting evolution since the initiative has matured and the different contracts have been awarded. In the early days of CLPS, companies chose their landing sites that suited their lander performance and safety. But with later CLPS contracts like this lunar delivery, NASA selected the landing site based on the data requirements for the agency's science and exploration goals. Mare Crisium was selected for this mission because it has a large impact basin. There's a lot of good data that can be collected here about the basin's chronology and the different volcanic features. It may also help us understand the volcanic history on the moon, including how it formed and evolved. This particular area was chosen in part to avoid magnetic anomalies on the lunar surface that could interfere with some of the observations we needed to take of the Earth's magnetosphere. The science teams also looked for things like rock abundance because there's a drill, but rocks can also be dangerous. especially during a landing. So finding that right balance was key. More than anything, NASA wanted to make sure that the science goals could be accomplished while also ensuring it worked for Firefly. Now, within Mare Crisium, Firefly will be landing in a particular volcanic feature called Mons Latré, which was named after a French scientist who is considered the father of modern entomology. In fact, he named dozens of insects in the Lampyridae family, commonly known as fireflies or lightning bugs.
And naturally, the Firefly team named the volcanic feature Mount Firefly.
So I was told that.
Are there any other goals that NASA is actually looking to conduct while we're there?
Yes, there is one goal I wanted to highlight. It's personally my favorite goal. So another one of the science goals NASA is looking to do is looking at the limb or horizon, so before, during, and after a lunar sunset. And that said, the location of Mare Crisium also allows us to capture visuals of the lunar sunset after Fireflies operating on the moon for a complete lunar day, which is about 14 Earth days. There was one person who saw this in real life, and that was Apollo legend and former NASA astronaut Eugene Cernan. He captured this unique phenomenon during Apollo 17, where he observed somewhat of a horizon glow. Something about this glow actually caused the lunar dust to levitate from the lunar surface. So in order to share this with the science community, Cernan sketched this phenomenon that we can see right here on our screens. Now, NASA is interested in seeing this again over 50 years later through the eyes on Blue Ghost. Firefly is ready to capture this phenomenon during lunar dust conditions and further prove what the last astronaut to walk on the moon saw taking place.
That's a moment I'm truly excited to witness and share, and maybe make a little postcard and send something out. Let's go ahead and take a closer look at Firefly's Blue Ghost lunar lander.
Firefly's Blue Ghost lunar lander was designed for stability.
Okay, I think we've got, they had to cut the audio from because of the copyrighted music, but I'm going to go ahead and answer a couple of questions real quick. The question in terms of why are they landing at this particular location? Landing at the lunar South Pole is a very difficult thing to do, and they're only going to do it if there are experiments on board that are absolutely needed for a polar environment. In other words, are these experiments going to directly correspond to a South Pole environment? If not, if these experiments are not, it isn't necessary to put the lander at the South Pole to carry out these experiments, then they're going to put it down someplace else. Although this location is definitely still a very interesting location. There's a lot of things about the volcanism on the moon, volcanic history of the moon that needs to be studied here. And also a lot of the experiments that are on board that are oriented towards Artemis don't have to go to the South Pole in order to be carried out successfully anyway. So that being the case, it's better to not land at the South Pole if you can get away from it. It is a dangerous place to go. There are people who are still arguing right now, actually, that we shouldn't set down at the lunar South Pole, that there may be water resources elsewhere on the moon where it's going to be a lot less dangerous to set down. The South Pole is a very rugged place. Lots and lots of mountains and hills and rocks. It is much, much more rugged than any of the Apollo landing locations. So there could be an issue. There could be an issue. Jeremy, I'm going to have to hold off on that because this isn't a UFO thing. Let's go ahead and bring Firefly back, and I'll talk a little bit more about that, Jeremy.
You feeling? How is the team feeling?
Yeah, I'm feeling good. I think the excitement is rising. I'll say the Mission Ops Center right now is actually like really calm. So that's nice. The team's practiced this many times, so I think they're just ready for it to happen now.
The viewers actually just got a quick look at Blue Ghost, but I'm sure there are a lot of questions about how the lander's performing now that she's in space and almost at her destination. What has surprised the team the most about how the lander's been performing during this transit?
Yeah, that's a great question. I think the lander is really, I mean, it's really behaved really well. We haven't had any major anomalies, which is fantastic. I think the team's kind of had to get used to, different alarms, kind of calibrating those. We started off really conservative, so we kind of had to gear in on that. Also, coordinating with 10 different payloads can be kind of complicated, but so far it's gone really well. So that's
Awesome.
that's a plus. Yeah.
And Ray, I really wanted to hear about the design and manufacturing process. Can you tell us a little bit more about that?
Yeah, absolutely. So a lot of our Blue Ghost is built in-house, which is amazing. I'd say really focusing on our vertical integration. There's a lot of carbon composites on there. I think all of our primary structures are carbon composites made up at our rocket ranch. So are our core avionics, our harnessing, our battery, and like all of our fluid lines. So going into this, we really wanted to build a really robust system, but also a really like structurally sound one. You look at our lander and it's a little bit shorter, it's a little bit wider. So we're really designing it for stability on the moon.
Awesome. So, of course, we talked about the RCS thrusters a little bit, right?
Yeah.
And so we like to lovingly call those Spectre.
Yes.
They're a 200 Newton hypergol engine, which we started development for in mid-2022. And by that December, we were already doing the testing.
Yeah.
And then in 2 years, we did all of the development, the qualification, the acceptance testing, and then we built all of the 8
So
flight
fast.
engines. Right.
Yeah.
So, Bridget, you worked on these RCS thrusters, if I
Yeah.
remember correctly. Do you want to tell us a little bit about that evolution or that process?
It's a lean team, right? So we started 2022 with maybe 4 people, not even 30
Maybe.
years old.
Yeah.
Yeah, exactly. And it was just such a fast turnaround with all of that development, that energy. We learned a lot from NASA and previous Apollo missions. We took that heritage, and through all of that iteration and testing, we've had some pretty successful firings so far in space.
Yeah.
That's definitely a fast and furious trip to the moon that's led us to today, but inspiring just to say the least. So, Ray, thank you so much for being here. Bridget, thanks for your insights. We want you to get back to mission control, but we'll catch you hopefully after the landing.
Yeah, I'll see y'all after. Thank you.
See you later.
Bye.
In 2018, NASA started a new, very different and innovative approach for doing science on the moon. As NASA explores the lunar surface under the Artemis campaign, we want to leverage the capabilities of American companies. So rather than NASA owning the missions and operating traditionally, we made a concerted effort to use commercial services and public-private partnerships. And Commercial Lunar Payload Services, or CLPS, was born. Let's take a closer look at NASA's CLPS initiative, which is helping bringing Firefly's first mission to life.
Our moon. It seems so close in the night sky, but getting there is really hard.
Once again,
what if there was
we have copyrighted music on that, but let me go ahead and explain CLPS to all of you, for those of you who are unfamiliar with the program. The objective, of course, with Artemis is to put humans back on the moon for the first time in over 50 years. But the idea first is to do a number of unmanned missions to the moon, as happened during the Apollo program as well, to determine as much information as we can about the lunar surface that we didn't get the first time around. Radiation being a very, very important factor that we need to have a better understanding of, simply because astronauts are going to be on the lunar surface much longer than they were in the past. And so therefore, cosmic rays and solar radiation are going to be a much bigger issue for astronauts. But there are many other things. The presence of water. It's now been determined that there's a little bit of water in almost all lunar regolith. And we didn't know that before. And of course, there's an enormous amount of water at the lunar South Pole, billions of tons of ice at the lunar South Pole that we can exploit. This, of course, is useful. This, of course, is useful not only for drinking water, but also for oxygen, for life support, if we can make use of that, the oxygen obviously in water. And also we can use the oxygen and the hydrogen to manufacture rocket fuel, hydrolox, which is a fuel used by the space shuttle's engines, the liquid engines on the space shuttle anyway, and the upper stage engines on a wide variety of different rockets uses hydrolox. So we need, here we go. We're going to go ahead and bring them back now.
And we expect to gain signal in approximately 10 minutes after Blue Ghost emerges from the far side of the moon. While we get ready for that next set of milestones before landing, let's take a moment to talk through this flight manifest. This is the largest payload manifest on Eclipse delivery with 10 NASA science and technology instruments on board. Diving right into the NASA payloads on this flight, we have the Next Generation Lunar Retroreflector, or NGLR, which is a passive instrument, meaning it does not power on. Instead, it will beam incoming laser light from Earth back in the same direction. The time it takes for the light to bounce back can be used to calculate the moon's shape and distance from Earth. Another payload on this flight, the Lunar Environment Heliospheric X-ray Imager, or LEXI, will aim to capture the first global images of the magnetic field that shields Earth from solar radiation, providing insight on how space weather impacts us here on Earth. During transit, LEXI operated for more than 50 hours total in preparation for collecting images from the lunar surface. Now let's talk about RADPC next. RADPC is the Radiation Tolerant Computer Demonstration. You can't send just any computer into space. That harsh environment in space and on the moon can lead to malfunctions, system crashes, and permanent damage. Designed to recover from issues created by radiation, RADPC provides a cost-effective solution for a radiation-tolerant computer, which, if effective, could improve the safety for future Artemis missions. Now, during transit, RADPC successfully operated while passing through the Earth's Van Allen radiation belts, a positive sign that the computer is working as intended. Next up, we're going to talk about the Lunar GNSS Receiver Experiment Payload, or LUGRA. We discussed earlier is jointly developed by NASA and the Italian Space Agency. LUGRA is investigating whether Earth-based global navigation satellite systems, or GNSS signals like GPS, can be used for space-based positioning, navigation, and timing from a spacecraft's initial launch to lunar landing. During transit to the moon, LUGRA successfully tracked GNSS signals from GPS and the European Union's Galileo constellations and broke the record multiple times for the farthest GNSS signal acquisition ever, peaking in lunar orbit at 243,000 miles from Earth. LUGRA's signal reception on the moon's surface could mean a lot of things for future Artemis missions and the space sector. These are just 4 of the 10 payloads being delivered to the moon today for NASA. So let's head over to Antonia Jaramillo to learn more about SCLPS and EDS, some of our dust instruments on this flight.
Thank you, Nilüfer. We are here at our viewing location for Firefly's moon landing, and joining me is Kristen John, the technical lead for NASA's Lunar Surface Innovative Initiative. Kristen, thank you so much for being with us here tonight.
Thank you for having me. Glad to be here.
Now, Kristen, you're kind of the expert on all things lunar regolith, or lunar dust. Can you tell us why it's so important that we study this?
Yeah, absolutely. So if we think about where we're going tonight, to Mare Crisium, and every location that we go when we go back to the moon, we're learning something new about the sites that we're going. We're going to learn a lot of geology from studying the lunar dust and the lunar regolith. But from an engineering perspective, it's actually really interesting and really important that we study the dust or the regolith. So we learned from Apollo what a huge challenge and what a huge barrier the lunar dust can be for all of the equipment that touches the lunar surface. So if you think about the household dust that we have, that's not what the lunar dust is like at all, right? So we have a different environment on the moon. So on Earth, we have an atmosphere that protects us, but on the moon, we don't have an atmosphere. So over the billions of years that the moon has been around, it's been bombarded by these impacts and by meteoroids. And so that's created this, these impacts that have created this fine dust. So we have this really small particulate. And then on top of that, because we don't have erosion on the moon like we do here on Earth, the particulate is also very sharp. So it's much more like fine pieces of glass or shards of glass. And then on top of that, we also have this electrostatic nature of the dust because it's very dry and because of the different properties of the environment. So now you have this small, sharp, sticky dust. So when you send any equipment there, it affects literally everything. So as we go back with Firefly tonight, or this morning, I guess, and any mission that goes back to the moon, we're going to learn so much more about the hazards of the dust and how we can improve with every mission that goes back.
And on this mission, one of NASA's science instruments is the electrodynamic dust shield that's going to actually help us, mitigate that lunar regolith. Can you talk to us a little bit more about that instrument and how it's going to also help our future astronauts when we go back to the moon?
Yeah, absolutely. So EDS is a fantastic technology. So it's an active technology that actually has these transparent electrodes on different surfaces. So you can put it on a radiator or a solar panel or glasses or camera lenses to protect them. And it basically creates an electric field. And when you see it work, it looks like magic. But it basically creates an electric field that gets the lunar dust particles to basically walk off of the surface, whatever the surface is. So you can imagine in the future, any surface that might have dust that accumulates on it, which will be a lot of surfaces, whether that's a visor on a spacesuit helmet or camera lenses, even spacesuit material, you could use something like EDS to literally walk the dust off of the surface.
That is so cool. Kristen, thank you so much for joining us. Now we'll send it back to our hostess, to Nilofer and Bridget.
And thank you, Antonia and Kristen, checking back in on Blue Ghost status. The team here in Firefly's Mission Operations Center continue to track the lunar lander as it begins its next set of maneuvers.
Alcon. Blue Ghost lander has achieved nominal descent orbit insertion delta V for lunar landing.
That is fantastic news that we just heard right
Here
there.
we go.
We're proceeding.
Alcon, journal log.
Thumbs up, guys. They're going for it.
Consoles, we're proceeding to step 45.6, post DOI and blackout lander status check. Starting with payload.
Nominal.
Com.
Nominal.
Ground software.
Nominal.
Flight software.
Nominal.
AVI.
Nominal.
VNS.
VNS is nominal.
GNC.
Nominal.
FIDO.
Wait 3.
Copy. Prop.
Standby.
Copy. TCS.
Nominal.
Systems.
Holding.
Copy. FC.
Nominal.
Copy. Holding for FIDO and prop.
All right, we heard some of those call outs right there. So teams actually are a little bit ahead in terms of gearing up to attempt. They performed the descent orbit insertion. The DOI took place on the far side of the moon. During
Flight
DOI,
nominal.
Copy.
all right, we're hearing calls out. Everything continues to be nominal, but during DOI, teams were actually in that planned communication.
Flight prop is nominal.
Copy. Systems.
Systems nominal.
C.
C is nominal.
Copy. All consoles nominal, post DOI and blackout.
Fantastic news. So we came out of that communications blackout and we completed
GNC,
that.
verify 45.7.
So we completed that DOI, that descent orbit insertion, and we are coming out from
Alcon and
that.
Ops, please be advised that there is 7.5 minutes until we start our slew from Suntrack to BNC Vector. This slew will orient the vehicle from pointing at the sun to pointing along the anti-velocity vector, and this will be one of 3 remaining slews of the mission. The second slew will occur when we switch our ephemeris to use the navigation filter solution. This is expected to take about 10 seconds, which means that we may or may not observe this in our live telemetry data rates. The third and final slew will occur about 6 minutes before ignition, and this will take us from pointing along the anti-velocity vector to pointing along the final descent vector in preparation for the braking burn.
All right, so those are just some of the nominal call outs. We were expecting a little bit ahead of schedule. And Bridget, we did tune into the Mission Operations Center to hear some of those nominal call outs. But can you give us a little sense of what we can expect next?
Alcon and Ops, this is VNS backroom. After reviewing the logs, I've seen successful configuration in video mode on all 10 Argus cameras.
That is wonderful news.
And you can also see those gauges have started to update now that we have that acquisition of signal.
Alcon, FC on Ops. Want to note that in about 9 minutes, we are going to have an LGA swap during that slew that was just mentioned. We'll see a slight blackout for up to 40 seconds.
Now that's wonderful news. You heard it here first. Firefly just completed that successful descent orbit insertion burn. Blue Ghost will now continue to coast with all engines off for approximately another 20 minutes before that next milestone, that final no-go poll to begin landing operations. All right, so we do have something really fun while we wait for that next set of milestones. Bridget, you brought me a little gift here. It kind of reminds me of, it's reminding me a little bit of something I would maybe make a salad in, or maybe make some stir fry in. What do we have here?
Exactly. So this is one of our foot pads that we actually tested. And it's funny that you mentioned that it looks like something you might stir fry in, because we actually, for the first demo of this, we took an industrial walk and tested it. That went well. So then we actually leveraged our composite technology, and we made an actual prototype of what our foot pad is that we've flown here.
So what are we looking at here with this foot pad?
So, and it's actually pretty cool too, because in Apollo, we took a ratio of the lander mass they had to the diameter of that foot pad. So we took that same type of design, scaled it for our lander. And so that's what you have at the base here. And then you have a ball and socket joint here for the lander to allow it some mobility when it lands. So it's in a stowed position that's not quite perpendicular to the ground. And then once it lands and it starts contact with the surface, it'll snap perpendicular. And I'll spin this around here. And we actually have one of the connectors here. So when you see those foot pad sensors turn blue on your screen, what's actually happening is there's a brake wire that runs up this leg to this connector, and this will actually snap. And that disconnected joint is what triggers those foot pad sensors to turn blue. So pretty cool design.
And that's that graphic we'll see a little bit later on.
Exactly.
And so from what I understand, this is actually, that you said it's a real test article that was used before she went into space.
Exactly.
It's in really great shape.
It is. So successful design. I mean, you can see some scratches on the bottom, but we don't have any major dings or anything like that. Yeah, definitely very successful.
And you said that there is a way for some level of shock absorption?
Yes. So, I mean, we are planning to touch down at about 1 meter per second, but we are still designed for something as much as 5 Gs and only 2 legs landing. You know, we want to try to put in enough margin into this as possible so we're successful. And what we, I don't actually have a piece of the honeycomb core here, but you'd actually have a cylindrical section inside this lander leg that acts similar to something in your car that crushes. So it would be a plastic deformation of that core inside of here. So maybe anywhere from a centimeter to an inch of that will actually compress and absorb some of that shock from that landing.
I hope you have other goodies to show me a little bit later on, because I'm fascinated by this. And as we wait to learn more about about the mission, some of our other NASA payloads on board, will continue to talk a little bit more about those. So another instrument on this flight is the Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity, or what we know as LISTER. It's equipped with a drill and a thermal probe, which will dig up to a depth of 3 meters into the lunar surface and take some thermal measurements. By making similar measurements at multiple locations on the lunar surface, LISTER could shed light on the geological processes that shaped the moon. Now, next up, we have the Lunar Planet Vac, which is designed, it's LPV, and it's designed to collect lunar soil samples from the surface using a burst of compressed gas to drive the soil sample into the container, and additional instrumentation will then take images of the container's contents and transmit those results back to Earth. The LPV payload is designed to help test low-cost technologies for collecting and analyzing samples, improving our ability to search for water, helium, and other potential resources on the moon. We learned during the Apollo missions that lunar dust, or regolith, is very challenging to work with. It's extremely abrasive and actually clings to everything: gloves, boots, vehicles, and mechanical equipment. Now, next up, to learn about the potential challenges that dust poses to future Artemis-era missions, the Regolith Adherence Characterization Instrument, or RAC, will measure how lunar dust accumulates on different surfaces and materials. The data captured could help more effectively test, upgrade, and protect spacecraft, spacesuits, habitats, and equipment in preparation for continued exploration of the moon. NASA's Lunar Magnetotelluric Sounder, or LMS, will probe the interior of the moon to depths of up to 700 miles. Now, that's 2/3 of the way to the lunar center. The measurements will shed light on the differentiation and thermal history of our moon, a cornerstone to understanding the evolution of solid worlds. Now, while we eagerly await that next milestone, let's talk a little more about the team. As you can imagine, there are several people that have worked tirelessly to make this mission happen. And Team Firefly's Blue Ghost team are lovingly known as the Ghost Riders.
They are. And right now we have about 20 Ghost Riders on console at Firefly's Mission Operations Center just north of Austin, Texas, that you can see on the screen right here. In total, Firefly has more than 50 team leads that rotate on console throughout our 60-day mission, including transit and surface operations. These console leads represent key operations and Blue Ghost subsystems, including propulsion, thermal, GNC, avionics, payload leads, and more. They've been checking Blue Ghost health status and sending commands to the lander throughout the entire mission.
And Bridget, you come to us with this kind of experience too, right? You were on console for Blue Ghost launch, if I remember correctly, and for many other rocket test campaigns. What's it like being in that room? How does it feel?
High adrenaline, for sure. But it's a moment that you train for continuously. Take launch, for example. As a propulsion engineer, you've already been hands-on with the hardware from day one. You've worked on the valve design, you've tested the subcomponents, you ran the engine development, the qualification, the acceptance campaigns. By the time that you're actually on console, you've already been through so many iterations of tests, which all lead up to that moment. And Blue Ghost is no different. It might be our first mission, but this team has already run 6 engine test campaigns, over 24,000 engine starts.
Wow.
Along with valve and battery tests, thermal vac, shock, vibe, and countless ops rehearsals simulating every off-nominal scenario imaginable. And this team is they're ready.
Everything under the kitchen sink.
Exactly. And everyone, engineering, supply chain, business development, welders, all came together to make this happen. We asked them who they dedicate the mission to, so let's listen to what they have to say.
Okay, so here we go, guys. Boy, we had an interesting conversation going on in the chat. I'm just not even going to acknowledge it. I think I don't understand why anybody would show up here if they didn't believe that all of this was real, but in any event. That being the case, we are obviously less than an hour away from landing. I am hoping that we're going to get more footage from Firefly. There's been a lot of comments about that, and they do have cameras on this thing. They've been showing us an enormous amount of footage, actually, of all these orbital passes that the Blue Ghost has been making of the moon. So I don't know why they're not showing us live footage right now, unless they're trying to keep they're trying to minimize the amount of bandwidth that they're using for their internet connections back to Earth, perhaps. That could be something. It isn't necessary for us to see a live stream from this, and like I say, they may have a limited amount of bandwidth that they have. Right. Yeah. And also, in many cases, as my producer just pointed out, the NASA's communication network, the DSN, Deep Space Network, which they're using for this, by the way, just about anybody who goes to the moon or an interplanetary journey at all has to utilize the NASA DSN or an equivalent of it. And that network prioritizes certain types of data. So if you're going to prioritize a 4K view of your descent, a 4K view of the moon, purposefully, with no purpose behind it, because there really is no point to doing that. You need to instead prioritize the data necessary for landing. Then that's really going to present a problem. Now, they are definitely recording all of this, and I'm sure we're going to get a stream of the entire landing process from Firefly after the fact. But a live stream of it is more difficult when you're doing an interplanetary journey. Now, the reason that SpaceX can do it is because they're utilizing Starlink. It's all in low Earth orbit, and they have a massive, massive internet network available to them, a lot of broadband available to them in orbit. But if they were all the way out to the moon or Mars, for example, of course, nothing would be live from Mars anyway, because it takes anywhere from 8 to 15 minutes for light to get from Mars to here. But if they were to be doing that, it would be a lot more challenging. Interplanetary communication, and especially interplanetary streaming, way more difficult than anything we do in orbit. Let's go ahead and go back to Firefly.
In their everyday life for the last few years, thinking of this mission. They've met so many friends while working this mission. They've met their partners. So it's impacted a lot of lives, and it's not even on the moon yet. So.
And you've worked on both the Blue Ghost mission and Elytra mission. Can you tell me a little bit about the team dynamics? How does that work?
Yeah, there's a lot of cross-pollination, you know, a little bit of everything. The culture at Firefly is honestly fun to work on because you have people that are incredibly capable in their fields, but also just fun to work with. You know, everyone expects a lot of you. You have to own your piece and, you know, deliver for the mission because no one can get to space on their own. But at the same time, everyone's always willing to lend a helping hand. If you share a problem you're stuck on, or honestly even mention it in front of a lot of Fireflies, they're very eager to offer their help and make sure we can all get there together.
That's really exciting. And excuse me, Ariana, I think a lot of people that are watching this are seeing that you've started your career at Firefly. How did you get to where you are? What did you study to bring you to this role?
Yeah, so I was a computer science major in college, and so not an aerospace major, actually. And a lot of people don't have aerospace degrees that work in aerospace. There's a lot of jobs that are required to help us get there. And I applied online, and I'm not joking when I say this. I applied not thinking that I'd get it. Not humbly, I just applied as an exercise. Almost didn't do it, and it ended up really well. So I think about what would have happened if I didn't apply. So like Joseph said, if anyone is thinking about it, nothing bad can happen. Just give it a shot.
Yeah, take your shot. And I think I have to ask, because we just watched this wonderful tribute video, who are you dedicating this mission to?
Yeah, despite obvious contributions to me being here, my parents, I'd have to give it to them because I wouldn't be here without their constant support and their leading by example, I would say. And it's also not mine to dedicate, but I would also give it to the other Fireflies who worked on this mission. I've watched people pour their hearts into this, so I'll definitely be thinking of them when we land.
Is there a particular memory or experience that stands out in your mind in the last few years?
The last few years, all I can think about is the recent events. Yeah, there's so much craziness. I've learned that, you know, all the people behind these great technologies are just people, and they're always fun to work with. Recently, honestly, the memory coming to mind is doing push-ups in the operations room. Once we launched Blue Ghost, we've had, 24-hour comms since launch, and even during the blackouts once we entered lunar orbit, where there's always people in the room, we never leave console. So that's a lot of overnight long shifts, and so you got to do stuff to stay awake, and that's been my life.
Take out that nervous energy,
exactly,
maybe too.
We're all supposed to be swole by the time we land. So.
All right, thank you so much for being here, and thank you for your contributions to the mission. We look forward to talking to you after landing. Now, through CLPS, NASA is buying a complete robotic lunar delivery service. Under this innovative model, NASA is one of many customers alongside commercial companies, universities, international partners, all with the common goal of sending payloads to the moon. Now, there are risks, and NASA is embracing a higher level of risk tolerance by leveraging commercial solutions to send rapid, low-cost deliveries to the moon, fostering a growing lunar economy. Let's take a look.
Landing on the moon is hard.
All right. So once again, guys, we have copyrighted music here. But in terms of a lunar economy, which I'm not sure exactly what they're talking about in the video, but I can address that issue. There's actually a lot of extremely valuable minerals on the moon. Lithium, probably being one of the most useful. One of the biggest problems that electric vehicles represent, and of course lithium also needed for this, the batteries in your cell phone, is the damage done by the mining. There's so much mining that takes place mostly in Central Africa. China owns the vast majority of all of this stuff, and the damage that they do to the environment is incredibly bad. Not only that, they make use of child labor to get a lot of this stuff. It is an evil industry, lithium. It really is. If you were to exploit this on the moon, then there's no damage to any environment. There's nothing to hurt up there. There's no ecosystem to hurt up there. There's obviously no children to manipulate up there. And so you can get an enormous amount of resources out of the moon without damaging the environment at all. Whereas extracting lithium here on Earth puts tons of carbon, tons of pollution into the environment. You're damaging the environment arguably more by getting that lithium as opposed to the carbon emissions that you're saving by having an electric car. If you can exploit these sorts of minerals on the moon, there's going to be a huge amount of benefit for it. And then on top of that, in addition to that, there's so many other types of resources. There's titanium on the moon. There's all kinds of rare minerals and rare earths that are, some of them are worth millions of dollars per kilogram that we can get on the moon. And by the way, China hasn't missed this. They are aggressively pursuing lunar mining and establishing a lunar economy. They are ahead of the curve on this, actually. They have a substantial lead when it comes to exploiting lunar resources compared to the rest of the world. And it's pretty critical that we get caught up on this unless we want the People's Republic of China to grab yet another monopoly. They have so many monopolies economically as it is right now. We absolutely need to take advantage of these resources. And it's not just the resources on the moon either. Asteroids have an enormous amount of valuable resources as well. Gold, platinum, things that are worth a substantial amount of money per kilogram, any type of valuable mineral that you can think of. Usually that's going to be available in space. Petroleum is the one exception, of course, because petroleum is the result of decaying biological matter. So that's something that's rather unique to Earth. Of course, who knows? There may have been a thriving ecosystem on Mars at some point in the distant past, and there might be petroleum on Mars. But right now, this is the only place to exploit petroleum. But yeah, so a huge amount of benefit to exploiting the moon. And of course, all the water at the lunar South Pole can be used, as I said before, for drinking water, for oxygen, and for rocket fuel. Hydrogen and oxygen can be used to manufacture rocket fuel. Let's go back to Firefly.
The landing on the moon, that's coming up, is very, very exciting. So I'm very excited for this moment.
Same here. Now, Janet, can you tell us why it's important that we maintain an American presence on the moon?
Well, I think this administration really wants to keep America first. And I think the way that we keep America first is by dominating in all the domains of space. And the space domain of space we're going to capture tonight is going to be on the surface of the moon and around the moon. So as long as we keep dominating that space, I think we're going to be putting America first. We're going to make America proud. We're doing this for the U.S. citizens. So very exciting, and I really think we need to keep pushing forward. And as it's been described all this evening, the Commercial Lunar Payload Services, this program, which marries NASA, a little bit of seed money with the commercial private industry, bringing them forward, building that lunar economy. Building that economy is what's going to make us dominate in and around the moon, so we've got to do it.
That's very well
Boy,
said. Now,
Kachina, thank you very much for your support. By the way, guys, one random Super Chat supporter is going to get some free merchandise personally signed by me.
Tonight,
and
you
that
heard about
merchandise is in that link
the study of the lunar surface and the soil and all that. But the one payload that I'm most excited about is the electrodynamic dust shield, because it was that technology was developed at the Kennedy Space Center, and I know that team is so excited to see that technology go to work on the Blue Ghost. And I think everyone remembers from Apollo the difficulty of all the dust and how it would cover the cameras and on the vehicle itself and the solar panels. And so by having this electrodynamic dust shield, it'll prove out that technology, which the dust will not be a problem, hopefully, as we go forward.
You know, I'm really excited of learning of that one myself. And just like you, I'm also a Kennedy gal, so huge shout out to the EDS team. Now, Janet, is there any message you'd like to say to our public here as we get ready to land on the moon?
Yeah, I would say thank you to everybody for their support. And I would also in particular like to thank the Firefly team. Earlier today, I was talking to Jason, and he was talking about his team of people, and I got to see a couple of them, but I can tell you they are motivated, they're dedicated,
Wow,
they're
boy,
relentless.
Katrina, thank you.
Thank
you so much for your generosity.
And they're really going to be successful. And then to the NASA teams
helps
that has
in a
all
big
worked
way.
very hard to get to this moment, I want a huge thank you and shout out to NASA, the CLPS, the Science Mission Director, for all they've done to make this moment possible.
Well, Janet, thank you so much for joining us here today. Now we'll send it back to Nilofer and Bridget.
Thank you both for those insights, and shout out to KSC. We are now in the final moments of descent. If you're just joining us, this is the NASA Firefly lunar landing broadcast for Blue Ghost Mission 1 as part of the agency's Commercial Lunar Payload Services, or CLPS initiative. With just less than 21 minutes before touching down on the lunar surface, the team is planning to conduct that final go, no-go poll for the Powered Descent Initiation, or PDI, in about 5 minutes. Now, while we get ready for that, I know there are a few more steps before the actual touchdown. What can we expect in the upcoming descent phases?
For our next descent phase, Blue Ghost will perform a fully autonomous powered descent initiation, which is a 9-minute braking burn that utilizes all engines to reduce Blue Ghost's orbital velocity from 1,700 meters per second down to just 40 meters per second. It's during this time that Blue Ghost uses D'Souza guidance to position itself above the target landing site, where we'll pitch over from a horizontal to a vertical orientation.
And if you're not familiar with D'Souza, it's considered the optimal guidance law for planetary lining. And Christopher D'Souza is credited for this. D'Souza's model is actually very similar to the guidance model used during the Apollo moon landings.
Exactly. And during the D'Souza guidance phase, Blue Ghost is fully autonomous.
No pressure.
We won't be sending any more commands to the vehicle until we touch down on the surface. We trust the lander to do what she was designed to do. Following D'Souza, Blue Ghost will enter the terminal guidance phase at T-minus 100 seconds to touchdown. Blue Ghost's main engine will shut off, and our RCS thrusters will perform the final descent by pulsing as needed to reduce our descent rate down to just 1 meter per second. So it's like a slow walking speed. It's during this phase where our vision navigation system is actively scanning the lunar surface, assessing things like craters, slopes, and rocks to automatically select a hazard-free target that's within our landing zone. Starting at T-minus 11 seconds to
I'm dying. There's a little dollar sign at the bottom of the chat. A little dollar sign and what looks like a dollar bill down there. I appreciate the question.
And I'm already feeling those nerves. That landing descent profile has to be precise. It's very, very impressive. Now, throughout this entire descent, do you keep the engines firing, or do they all shut off? What can we expect there?
Great question. So those Spectre engines we spoke about before, they're designed to pulse. They give us a very fine-tuned control during descent. Each of those engines fires 4 times in a second, anywhere from 60 milliseconds to 235 millisecond bursts. So about as quick as a bird flapping its wings, or as long as a blink of an eye. Then, once the lander's foot pads detect contact with the surface, they send a signal for the engines to cut off. And what you see on the screen now is a visualization of these contact sensors to show which of those foot pads have successfully touched down on the surface.
Now, that procedure sounds so simple when you explain it, but we both know how much work it got to get to this point.
Wow,
We know how we are
Patrol.
going to land, but
Thank
what
you
will we
so
see?
much.
And most importantly, what about the
The
pictures?
American Ocean.
So to set the stage,
Thank you very
there's
much,
two types
Patrol.
of antennas that we talk
Wow.
about here. We have an S-band
Blow
antenna,
my
which you
mind.
can kind of think of as
Thank
our
you.
lower resolution SD antenna.
By the way,
and then you have
this
your
support
X-band or our high resolution.
allows me to go on
Plan
site
is
to
to use
actually
our S-band
bring
antenna
you
to
these
send our
launches in
first images,
person.
hopefully within about
And I
30
can't
minutes of a
wait to
nominal
bring
landing.
you the
But if
next
that
one.
data rate is too limited,
Hopefully
we're going
from
to switch
Shetland
to
here in the
X-band.
United Kingdom.
This takes
First
a little
ever
bit
launch
longer to
from
deploy and
Western Europe.
calibrate, but once it's up, we're going to have a much faster downlink for high definition images and video.
So that was really helpful, and hopefully we can expect those images to come in shortly after we touch down on the lunar surface. So at this point in time, we got a little preview of that landing sequence, and thank you so much for sharing what we can expect. I'm really excited to see those first images.
Step 47.2.
So we heard that call for that go, no-go poll. Teams have been training for this mission and are now getting ready for that go, no-go poll ahead of that PDI we talked about, or that powered descent initiation. Here's what to expect now. If the poll's a no-go, Firefly does have another opportunity to do another orbit around the
Falcon
moon.
and Ops. Slew has begun to our final descent vector. 1 minute until slew completion. GNC verifies step 46.2.
So as I was saying, based on how this goes, if we are a no-go, then we have another shot at orbiting the moon and doing a powered descent initiation. But if we're go, Blue Ghost will take the wheel and perform that autonomous descent operation Bridget just went over with us. Now let's
GNC
go.
verifies step 46.3.
We're going to go
Falcon
ahead.
on ops, 5 minutes to power the descent ignition.
Perfect. We heard that 5-minute call
All
out.
consoles 1 minute away from PDI go, no-go poll. Step 47.2.
Let's tune into the Mission Operations Center and listen for that poll.
Here we go. Come on, guys. Come on. Let's go.
So what y'all are seeing on the screen here are those positions in the Mission Operations Center, and we'll see those light up as they give their go or no-go commands.
And on our screen right now, we are seeing our flight director, right?
That's right. So that's Charles right there. He's our flight director for this mission.
Lars, thank you so much. Thank you so much, and you're welcome.
Falcon on Ops.
Thank you, Lars.
Slew is complete. GNC verifies step 46.4.
Right. Everything continues to remain nominal as we stand by for that go, no-go poll.
Falcon on up. VNS is reporting position covariance below 50 meters.
And that VNS is our vision navigation system.
Thermal state is 11.
Mooti, another
We will be starting
massive
PDI
super
at
chat.
97%
Wow.
state check.
So we had a pro-American
consoles, flight
ocean.
ops,
Now we
PDI
got
cannot be aborted if
an
the lander has transitioned
anti-Elon
to
Musk
descent
statement.
critical.
Okay,
Also at
I'm
this
not taking
point,
any
we're
sides on
proceed
any
with
of that.
power
All I'm
descent
saying is
initiation,
I
go, no-go
super
poll, starting
appreciate
with
you
payload.
guys' help.
Go.
It makes a huge
Com,
difference to
go.
what I can
ground
do
software,
with
Go.
this channel.
flight
These
software,
are massive,
go.
massive super
AVI.
chats.
AVI
Guys,
is go.
I am so grateful. Thank
VNS.
you so
VNS
much.
is go.
GNC,
Go.
FIDO,
Go.
prop,
Go.
TCS,
Go.
systems,
Go.
C,
Go.
FC.
Go.
All
And y'all-
consoles,
Yes.
Blue Ghost landers a go for power descent initiation.
And y'all heard it from
Falcon on ops,
Charles.
3 minutes
Here we
remaining
go,
until
baby.
power descent initiation.
Here we go.
We are go for the powered descent initiation. In the next 15 minutes, we're going to tune into our Mission Operations Center as the team monitors the vehicle and prepares for that final descent.
Now, there are some of those visuals that you were describing earlier in the show, Bridget. So we can see our countdown clock where we're about 14 minutes, just almost under 14 minutes from landing. And we have that visualization of Blue Ghost as it's continuing its horizontal trajectory, getting ready to get into that vertical mode.
Exactly. And so, like we said before, that's real telemetry that's driving that simulation y'all are seeing on your screen here. That yellow vector you see off to the left, that's pointing in the direction of the sun. And that blue vector there is the direction of the Earth.
And we see those foot pads as well as all of the engines in this image. So really exciting to see our MOC, our Mission Operations Center, as well as that data-driven telemetry.
All right, folks. So yeah, now they are committed. There's nothing they can do
Right,
at
if
this
you are
point.
just-
There's
All
no
2 minutes remaining
opportunity
to power
for a
descent.
second chance at this. They are in a
With
descent
that 2-minute call
trajectory.
out, if you
There's
are just
no
joining us, this is
stopping
the
it at this
NASA
point. They're either going
Firefly
to
joint
land or they're
broadcast
not going to
for Blue
make it.
Ghost
So
Mission
yeah,
1
go
as
Firefly,
part
go
of the
Blue
agency's
Ghost, go
Commercial
at
Lunar
NASA.
Payload Services
Dying,
Initiative.
thank you so
We are
much.
standing
Wow,
by
the
as
generosity. Your first
PDI
ever super chat.
process and
Go Blue
procedures
Ghost
do
for it. Thank
continue.
you so much.
Just as
Really
a reminder to
appreciate
those of you who are tuning in, the graphic visualization that we do see is has about a 15-second delay, and we did cover that at the top of our broadcast. So just as a reminder, there is that 15-second delay. So we may actually hear that call for landing before the data does get there, but we would like to point that out and keep that in mind as we continue to follow along.
That last call out you heard was propellant settling. So
Just so you know, the odds are against Firefly on this. This is their first attempt of trying to land on the moon with a very inexpensive lander here, a lander that was designed to make money. So we will see, but they definitely have a tall hill to climb on this first attempt. If they pull this off, they will do something that no other company has been able to do. No other American company, actually no private company, period, has been able to do if they pull this off.
I'm learning so much today.
30 seconds.
And again, we can't get real-time animation because it consumes a lot of internet bandwidth, and they are making use of the NASA Deep Space Network on this, not Starlink. There's nothing orbiting the moon to allow for high-speed internet. So as a result, they can't prioritize
10 seconds to PDI.
just a live stream of what we're seeing, unfortunately, because that would put a lot of important data, a lot of important information that they need to get from the lander on the back burner. They can't do that. So they're recording all of it, though. We will definitely see all of this in the near future, but I understand why they can't do this. If they were orbiting the Earth, it would be a different story. The moon's a lot more difficult.
Reduce. And you can see that on the simulation right there with
Main
the
engine
engines going. Main engine is on. We see that.
Descent critical.
All console slide on ops and abort is no longer possible.
Thanks so much, 123, for the $5. Thank you so much. Man, all this generosity today. You guys are blowing my mind. Thank you so much.
And this is where the lander is positioning itself closer and closer.
Ignition temperature's nominal.
Nominal callouts.
Guidance mode, D'Souza, 48.1 confirm.
Have you heard that D'Souza guidance?
Attitude and rate errors look like they converge back to nominal after the transition.
Current draw is nominal.
Tank pressures are stable, prop is nominal.
And remember, this burn lasts
VNS is stable, nominal.
about 9 minutes.
Navigation filter is well behaved.
We love when things are well behaved.
Exactly.
We just heard the call. That comm is stable as well.
Comms link is stable.
It's during this burn where we were going
All con ops, 9 minutes remaining to pitch over. 455 kilometers south of the target, 16 kilometers above it.
We're reducing our velocity down to 40 meters per second in this burn. And so on that gauge, what you'll be looking for is about 144 kilometers per hour.
And just as folks are tuning in right now, our PDI is actually that braking burn.
Exactly.
So we're continuing to slow our speed down and bring the vehicle from a horizontal configuration or horizontal orbit into a we're pitching over the lander into a vertical configuration.
Exactly. All of our RCS engines are firing.
You can see that velocity dropping off quickly. We were well at about around 5,500 kilometers per hour about a minute ago. That braking burn doing its job. I am actually surprised that they were able to get this right on the first attempt for the landing trajectory.
Kilometers south of the target, 17 kilometers up.
Intuitive Machines wasn't able to do that.
So 1 minute completed.
This is very
of that
interesting.
9-minute braking burn.
Attitude and rate errors remain nominal.
All-con ops, VNS is passing over a shadow.
And so what you guys see on the screen here is that graph taking us through all of the different phases into landing. We are in that power descent initiation.
VNS is past the shadow and returning to lower covariance.
Main engine temperatures continue to rise nominally.
How are you feeling?
Excited, nervous, anxious. Lots of feelings.
7 minutes to pitch over. 290 kilometers south, 16 kilometers up.
Once again, in my opinion, the odds are against Firefly on this. This is their first attempt of landing on the moon. This company's first attempt. Brand new spacecraft. See if they can pull this off.
So we are seeing our various folks in the Mission Operations Center that are continuing to follow along during this.
Wolfgang, thank you so much. Thank
Power
you.
Descent
Really
Initiation,
appreciate it.
or PDI. All operations continue.
Engines trimming out, target achievable, 48.2 confirm.
Batteries at 92%.
In the front left of the room there, where the camera's pointing, you're going to see that's 100% of those teammates with us from ASI and Space NG. So you're seeing folks from ASI, GNC1, GNC2, FIDO. You got Space NG with Vision Navigation Systems.
6 minutes remaining until pitch over. 222 kilometers south, 15 kilometers up.
All right, we can hear that number.
Venus is crossing over the final ridge as we enter the Mare Crisium.
We're getting closer and closer to our landing site, Mare Crisium, on the northeast part of the moon, on the side that faces us here on Earth. Now there is a NASA console position as well.
That's right. They're on the opposite side of the room, probably in the corner.
3,500 kilometers an hour. Firefly's only, or Blue Ghost is only just a little bit higher than what a commercial airliner would be while flying over the Earth. So real close right now.
That's right.
And I think that's fair,
Navigation
right?
filter looks nominal, and Star Tracker is still in lock.
So she's sitting in our payload seat. So she is.
Anton, thank you so much. Moody, my God.
And she's been with
Moody
all of the
definitely
payloads
wants everybody to boycott anything and everything Elon Musk. And Anton, thank you so much for your long-term support.
5 minutes remaining until pitch
Moody,
over. 140
thank you so much.
south,
I can't say that I
13
agree with you.
kilometers up.
I can't say I disagree with you. I'm not taking
So
sides
Vera's
on
there
this, but thank
tracking
you. Thank
the
you
health
so
of the
much.
payloads and making sure everything is performing as expected.
Absolutely. Yep. And we actually have 3 payloads on site for landing. We have EDS, Lister, LPV. The rest will be remote.
So 3 out of the 10 payload teams are currently near the Mission Operations Center on site, and the remainders have their own control centers in other locations.
And so this is a primary operations
VNS is
center.
seeing drops to validate.
Boy, that velocity is dropping off fast now.
There's some backup rooms upstairs too for secondary, tertiary, and extra data review. Eyes up there.
So you talked about
4 minutes remaining to pitch over. 110 kilometers south, 10 kilometers up.
And on the screen right now, you see Joseph.
So yeah, now at this point,
Coogan.
Blue Ghost is at the
CEs,
same
our
altitude
chief
roughly
engineers.
as a commercial airliner flies.
Fun fact, Will
So
Coogan actually used to be a
yeah,
carpenter before he
the
went
ceiling
back
of
to
a
school.
commercial airliner.
Validate.
Very, very close now and dropping
I
off
think having all
fast.
these varying backgrounds really helps you in your current work. So it's really impressive to see this team coming together. And not only are we seeing the teams in the room, but there are folks that are in back rooms, as you mentioned, that are also supporting this mission
Batteries
today.
at 90%.
Exactly.
So we see that speed has come down.
VNS now sees we're back in global generating solutions again.
That's 7 kilometers from the surface. That braking burn continues.
Falcon and Ops. 3 minutes remaining until pitch over. 67 kilometers south, 7 kilometers up.
Getting closer and closer to that lunar surface.
Still nominal.
Attitude and body rate errors still nominal.
we were saying before, the Fireflies, we don't sit still in one position, one roll too long, and so we do.
Blue Ghost is now just dropping below 20,000 feet, or just below 6 kilometers.
Tracking this mission.
And plunging quickly, and that velocity is dropping off fast too. Man,
easing my nerves a little bit right
it
now
is getting close.
So that
guys, please don't forget to like. Please don't forget to subscribe. I think I have some new viewers here today. Please subscribe.
To put it in that
VNS
vertical.
is reporting position covariance below 25 meters.
Two minutes remaining to pitch over. 35 kilometers south, 4 kilometers up.
So right now, looks about 3.7 kilometers, about 12,000 feet or so.
Or braking burn.
Really close. And speed dropping off rapidly, roughly about, converting this stuff for you guys, about 800 miles an hour or so.
To pitch over.
Fighter Officer verify 48.3 when ready.
That was Charles.
Now at approximately 10,000. No, it's a lot less than that.
Structures.
Flight laser rangefinder has measurements.
At 8,500 feet or so.
VNS reports position covariance.
Still dropping off fast.
1 minute remaining until pitch over. 13 kilometers south, 2 kilometers up.
So when they do that pitch over, that's when they're really going to have to hit those braking thrusters, because this thing is still burning close to
our engineer
about 500 miles an hour or so.
On board the lander that he helped also build and test.
They're going to have to slow down a lot here when they do that pitch over.
So we'll see him come in later.
So we do see that graphic come up. We talked about a little later with the lander foot pads. So our contact legs will turn.
All right, we're at 1 kilometer, about 3,300 feet.
30 seconds remaining to pitch over. 4 kilometers south, 900 meters up.
Here we go.
So those will turn blue once we've confirmed some level of contact. And we'll continue to track as we get closer and closer to the lunar surface over the course of the completion of this PDI.
About 2,500 feet now.
Demonstrating that Blue Ghost is getting into that vertical configuration.
100 miles an hour.
Over as expected.
And engine off. Terminal guidance. 500 meters up.
Okay, here we go.
Battery's at 87%.
Right, from here on out.
Now it's on an automated descent, utilizing LiDAR to make sure that there's nothing, no obstructions, no big rocks, nothing in the way as it sets down. So it's going to be able to adjust its landing trajectory appropriately. Good Lord, Moody. I'm just going to repeat it. Elon Musk is a megalomaniac, narcissistic fascist. I just repeated what you said. Because, man, you sure earned it. Thank you so much for the $100. Man, Moody, just been unloading super chats. Thank you. Here we go, guys. Here we go.
Converged on his commanded descent profile.
It has dropped off big time. We're now at about 16, 17 miles an hour.
Ready and has been preparing for this.
Down. Oh, my God. Here we go, guys. Here we go.
About vision navigation solutions, laser
seconds remaining in terminal. 100 meters up.
And let's just
systems.
Navigation filters still healthy.
Second hazard avoidance.
Close enough to touch it now, guys. I like how this lander looks. I like it's the squat configuration, and it makes it less likely that it'll topple over. Come on, baby. Let's do it. Let's do it.
Copy. Verified.
Speed's looking good. Only 4 kilometers an hour. Come on, come on, come on. You can do it. You can do it. It's just hovering now. Just hovering less than a meter off the surface of the moon.
Vehicle shutdown.
That's it.
Contact sensors.
Touchdown.
Engine shutdown confirmed.
I'm assuming the reason it's showing that there's still some distance is that's just the height of the lander itself. So in other words, the sensor is located just a little bit off the surface, but we have a successful touchdown. The question is the lander still operational? Let's find out.
Here on ops. Y'all select the landing. We're on the moon.
There we go. They stuck the landing, guys. We have confirmation. They have stuck the landing for the first time in human history. Near as we can tell right now, we have a totally successful landing on the moon from a private company. Never, ever has this happened. Intuitive Machines did it to some degree, but they toppled over, broke their landing legs. It appears that Blue Ghost has not experienced those sorts of issues and has had a 100% successful landing on the moon. Go ahead. Sorry, producer. All right. So, guys, wow. Just an amazing thing here. Apparently we have some music going and stuff at the moment over at Firefly, but okay. So in any event, guys, just once again, look at all the celebration, all the excitement, and well-deserved over at Firefly. An enormous accomplishment here after one completely unsuccessful attempt and one that was only partially successful. The first one from Astrobotic that didn't manage to make it to the moon at all, unfortunately. Then the Intuitive Machines landing that, once again, as I said, broke landing legs, fell over, and therefore some of the experiments couldn't be carried out as a result. It made it, definitely, but not flawlessly. Near as we can tell right now, this was 100% successful. And if that is indeed the case, that means that this is the first time in over half a century that the United States has successfully landed on the lunar surface. And they've done it on a budget too. They've done it very affordably. That is a big, big plus as well. Far less expensively than any of the Apollo missions were able to do it for. If this is indeed as positive as it looks like it is right now, then this is a huge win for the NASA CLPS program and for Artemis and for mankind's return to the moon. Wow. Let's go ahead and bring Firefly back on.
Associate Administrator for Exploration with NASA Science Mission Director Joel Kearns. Nikki, Joel, I mean, what a momentous occasion. How are you guys feeling? We're on the moon!
So my question is, what do you think of that Firefly team?
It is such an exciting time. I mean, what a huge congratulations to everyone. Now, Nikki, can you tell us a little bit more about why this landing location was chosen and why, Blue Ghost is on the near side compared to when some other landing sites are chosen for other of our Eclipse flights?
Yeah, absolutely. We choose, I'm sorry, I'm just so excited right now, but we choose our landing sites very carefully. Our Eclipse landers will go to the South Pole.
Nigel, thank you so much for the tenor, my friend. Thank you, Nigel. Thank you, everybody, for your generous support today.
Features on the moon. We want to study the interaction with the solar wind. We want to just learn more about the regolith. We want to be able to prepare for our future astronauts to go and keep them safe. And so we chose the science instruments perfectly to go to this incredible place on the moon.
That we did. And Joel, this is the most NASA science that we have sent on Eclipse flight thus far. Can you tell us a little bit more then? What is the primary goal, or what are we hoping to find then with all of this?
So we're landing in a place that's of great scientific interest, but it was also at a very achievable place to land. And there are studies that range from studies of the sun that we'll conduct from the surface of the moon, studies of the abrasive dust of the regolith. We're going to drill into the surface. We're going to pick up regolith. It was going to answer so many questions over this one lunar day long mission. It's going to be really one for the history books.
That's right. And speaking then about all those questions that we're going to answer, Nikki, tell us, what then of the science and data that we learn on the moon, how can that help us back here on Earth?
So there are so many ways that, you know, everything we do in NASA science is so interconnected. We study everything from the center of the sun to the edge of the universe. Right now, focusing on the moon, learning more about particularly things like, you know, how that regolith, how it sort of interacts when we land, what the plume looks like, how sticky it is, if we can clean it off those surfaces, just telling us all about that. For us here on Earth, all this technology that we're sending up to the moon continually all has real-world applications as well. And so everything that we do, you know, coming back and serving humanity and inspiring the world with NASA science.
That's right, we sure are. You know, that's really fascinating. Talking more about, you know, some of the scientific instruments that we're sending. As we know, Joel, some of those science instruments have flown on prior CLPS flights, and they're also scheduled to fly on future ones. Why is that? Why do we choose some of the same instruments for certain flights and different ones for others?
Well, you know, we've only really been to a few places on the surface of the moon during Apollo or even with our robotic surveyor craft from the 1960s. There were a bunch of measurements we really wanted to take to characterize overall around the moon. Sure, especially the South Pole where our astronauts will go initially, but there are particular scientific questions where you have to take the same measurement on the near side or the far side in a mare, you know, one of these frozen lava pools, as opposed to the Highlands Mountains, to really understand the moon, and based on that, to better understand Earth.
Yeah, I can't wait for that. And, you know, Nikki, talk to us then about some of the lessons learned then that we have, you know, learned from now our other CLPS flights that were applied for this one or, you know, for the future ones.
Yeah, I mean, I think one of the amazing things about our CLPS providers is they are all there for one another. You know, even today, Jason was sharing stories about what some of the other teams have been sending. Good luck to Firefly today. It is just an amazing community, and that is what we wanted to do with the CLPS program, was really
Thank you, Philip. Wow, everybody's generosity today is blowing my mind. Thank you. Thank you. And it'll bring some great results, folks. Got some incredible stuff coming to you this year.
As NASA, we're doing this in partnership with these American companies. And so, you know, just seeing the community that we're building is just so, so amazing. And so just congratulations to everybody.
Yeah, very well put. I mean, to both of you, how are you guys feeling right now that we're on the moon?
I don't know, it's all in a day's work, isn't it? Really, it's, you know, it's a Sunday. No, honestly, it is so, so, so amazing. We were standing outside watching it, and Joel was getting instant, like, you know, feedback from all those amazing people in the mock. And it's just incredible it was just, I don't know, you know, seeing it come down and then you're suddenly like, oh my God, it's 5 kilometers above the surface. And so it's just an amazing, amazing achievement. I am so proud of everyone in this room because you all had a part in putting this lander on the moon, whether you're a Firefly or whether you're a family member of a Firefly or whether you're a member of the amazing NASA science team. Congratulations.
Ben Quest, thank you so much. Really, really appreciate it. Thank you.
Thank you, Nikki, Joel, so much for joining us. Now we'll send it back over to our hostess, to Nilofer and Bridget.
Welcome back for those just joining us. Firefly successfully touched down.
Producer, we're going to go ahead and cut
stable
Firefly at this point, if that's all
becoming
right.
the first commercial company to complete a
Yeah, we'll go ahead and do that at this point. All right, folks. Once again, apologies to Firefly, but at the same time, do need to wrap up this broadcast today. But also want to make sure that that everybody understands the significance of this moment. Somebody made a comment about how we need to make a fair comparison between this landing and the NASA Surveyor landings in the 1960s. The last time I checked, in adjusted dollars, the Surveyor missions were at least triple the cost of these CLPS missions, again, in adjusted dollars. So what was accomplished today is huge. This is a private company, sure, operating with a little bit of NASA assistance, but overall, doing this by themselves and setting down successfully on the moon for the first time, their first attempt with this spacecraft. That is a huge huge accomplishment. And I'll tell you, this was a win that NASA really needed, the NASA CLPS program. This is a win that Firefly is going to benefit from tremendously. I'm pretty sure that their stock is going to be skyrocketing on Monday because they've just proven that they are capable of putting payloads on the moon. And there's lots of other private companies, universities, other organizations that want to put their payloads on spacecraft. And Firefly just made a huge statement today. This is a big, big moment. Super, super excited about what happened today. So, folks, I want to thank you so much for tuning in. I want to thank all the incredible generosity that came over today from all of these amazing viewers and the super chat supporters. Thank you so much. Also, don't forget to check out the merchandise. We've got merchandise for alien fans, for UFO fans. We got stuff for SpaceX fans. We've got stuff for people who are just spaceflight fans in general, for the Hohmann orbital equation. Those of you familiar with that, the spaceflight geeks amongst you, we got merchandise for that, and also for the Apophis asteroid. So the link is at the top of the chat. Don't forget to check in on that, because that's another huge way to help out the channel and get something for yourself as well. Thanks again for tuning in, everybody. Until next time, stay angry about space.